Okay, so at the end of the last video, we were just about to finish this question. We were solving for the force. It's number 12, the force that you would need to push with to make it go up the incline at a constant speed. So the mass of the box was 55 kilograms times 9.81 meters per second squared times the sine of the angle, which was 33, plus the coefficient of friction was 0.23 times 55 kilograms times 9.81 meters per second squared times the cos of 33. And when you do this, you should get an F of 397.936 newtons. Okay? Number 13. Might not have room. I think I need to turn the page over. All right, so number 13. A new worker at a warehouse is pushing an 85 kilogram crate up a 28-degree ramp. So here's the ramp. So this angle here is 28 degrees. Of course, this worker didn't take physics, and so they are not pushing straight up the ramp. They are pushing into the incline. So this is the F. Coefficient of static friction is 0.46. It's static, which means it's not actually going to be moving, which means the AX is going to be 0. This is FGX, FGY, this is FN. It's going up the ramp, which means friction will be going down. This will be your FX. This will be your FY. This angle and this angle will also be 28 degrees. How hard does the worker have to push to start the crate moving up the ramp? So the first step is sum of the forces in the Y direction. And it's not going to be moving in the Y, so that goes to 0. So we have Fn minus Fgy minus Fy equals 0. So Fn will equal Fgy plus Fy. In other words, Fn will equal Fgy is mg cos theta, and Fy is plus F sine theta. Cannot find a value because you don't know the F. So now go to sum of the forces in the X direction. And the question says, how hard does he have to push to start the crate moving up the ramp? This goes to 0. So we have going up the ramp Fx, going down the ramp Fgx, and friction. And that's going to be equal to 0. Fx is F cos theta. Fgx is mg sine theta minus mu Fn equals 0. But this is Fn, so I need to go down here. So just because I won't have enough space over there. So F cos theta minus mg sine theta minus mu brackets mg cos theta plus F sine theta equals 0. So you're trying to solve for F, and there's one stuck in the bracket, so you need to multiply through. So F cos theta minus mg sine theta minus mu mg cos theta minus mu F sine theta, don't lose this minus sign here with the mu, equals 0. Take the two terms that don't have F in it to the other side, so it becomes F cos theta minus mu F sine theta equals mg sine theta plus mu mg cos theta. Now factor out your F, and it'll be cos theta minus mu sine theta equals the same stuff, and divide by the bracket. So F will equal mg sine theta plus mu mg cos theta divided by cos theta minus mu sine theta. And now fill in your numbers. So M was 85 kilograms times 9.81 meters per second squared times the sine of 28 plus mu was 0.46 times 85 kilograms times 9.81 meters per second squared times the cos of 28 divided by cos of 28 minus 0.46 times the sine of 28. And assuming you can type this into your calculator correctly, you should get 1094.68 newtons for part A. Okay, answer in the back of the book, by the way, is wrong. Part B then says, an experienced worker comes along and tells Buddy to bend his knees. So now the question becomes easier, because now he's going to push with just F, going straight. Push directly up the incline. How hard does he have to push now? So now everything goes back to just a normal question. FGY, FGX, there's no components of the force he's pushing with. Friction is going down. So in the y direction, it will just be Fn minus FGY equals 0. So Fn will equal mg cos theta. So much easier. Why you really need to take physics. And then in the x direction, max, it's still to start it to move, so that goes to 0. F minus FGX minus friction equals 0. So F will equal, because that's what we're solving for, mg sine theta. Take this over plus friction, which will be mu mg cos theta. So F will equal, M was 85 kilograms, 9.81 meters per second squared, sine of 28 plus 0.46 times 85 kilograms times 9.81 meters per second squared times the cos of 28. Not dividing by anything, this should be easier to type into your calculator, and you get 730.14 newtons, significantly less because you bend your knees. All right, so hopefully these were pretty good. You now have a sheet that you already did numbers 1 to 5 on, so I'd like you to do numbers 6 to 10. And then once you finish those, you can work on your assignment or on your lab, because we will be moving. We'll do a couple more tougher ones in person, and then we'll be adding other things to the incline, okay? So 6 to 10, please, for the, tomorrow.